Okay, yeah, so for the equation 2x minus xy minus 3x squared equals 4, let's find where the tangent line is horizontal. This is a problem that we visited before and we're revisiting now. What do we know about, we're thinking about it here, horizontal tangents? Well, what we know about horizontal tangents is the slope is 0. Yeah, a tangent line horizontal means the slope is 0. Which means what else is 0? The derivative with respect to y. And so that's where we're going here. We need to find the derivative and set the derivative equal to 0 and see where that takes us. Okay, so on this one, I guess there are other ways we could do this one, but the idea is to use the implicit differentiation to do this. All right, so let's implicitly differentiate this. So that would be 2. Derivative of that would be 2. Here I'm going to have to use the product rule. First, minus x times the derivative of the second. Well, that's y, so the derivative would be 1, but it's a y, so I've got to do dy dx. Plus the second y times the derivative of the first, which would be negative 1. That would be the derivative. Those two would be the derivative of that one. All right, then the third one here, the derivative of that's just minus 6x. Derivative of the right side would just be 0, so I wind up with 2 minus x dy dx minus y minus 6x equals 0. Okay, so I'm trying to find the derivative, so I need to get dy dx by itself, so I need to move these terms over to the other side, so that would be minus x dy dx, or we could, matter of fact, we could do it the other way this time, couldn't we? Move the dy dx over there, might be easier, but oh well. I've already made my arrows, so let's just do that. All right, then we just divide by minus x, and so dy dx equals negative 2 plus y plus 6x over negative x. With me? Okay on that. All right, but the original goal was to horizontal tangents. And where's the tangent line horizontal? When the derivative is 0. Here's my derivative, so I'm going to set my derivative to 0. 0, then I need to find out where 0 equals negative 2 plus y plus 6x over negative x. And here's what you're going to run into a lot of times when you do such a thing. What we run into, well, first of all, what about that? Well, one thing, of course, I could do here to simplify it a little bit is I could, what about the minus x? Multiply both sides by minus x? All right, so yeah, let's multiply both sides by minus x. Because that'll cancel the minus x out then. Of course, this side will just be 0. Okay. But we're still left with a predicament because, how about that? Well, the problem is I've got two variables, so I can't solve and find a number answer. Okay? But what I can do is this. I can get a y equation out of this. So let's solve for y here and see where that takes us. You know what I mean? Go ahead and get the y by itself here. So let's move, well, basically move those back over. So it'd be add 2, so it'd be 2, subtract 6x. So I get 2 minus 6x equals y. What that gives me is a relationship between the y and the x. That kind of tells me the tangent lines are going to be horizontal when one of the relationships anyway between x and y is this. Okay, but that's really doing me no good because I want to find points, values. X equals this. What is it? Well, the deal is, here's what I can do with this. What I can do with this is, it's a little substitution problem, I guess you might say. If I take, isn't that saying y is equivalent to 2 minus x? So what I can do is take that and plug it in here for y. And won't that give me just an exclusive equation in x? An equation exclusively in x, I should say. So you see what I'm doing? I'm just dropping 2 minus 6x in for y here. So that would be 2x minus x times 2 minus 6x minus 3x squared equals 4. So essentially what I'm doing is I've got a system of two equations now. I know x and y are related two ways, and just solving the system here. You with me? See what I did? See where I got this? All right, so what does that make? It makes it 2x minus, that'll be, just sure that'd be minus 2. Hey, that's nice. And then minus x times minus 6x would be positive 6x squared minus 3x squared equals 4. Works out nicely, doesn't it? 2x minus 2x, that's gone. 3x squared minus 6x squared minus 3x squared is 3x squared equals 4. So now I can figure out what x is. Divide by 3 here. So x squared equals 4/3. What's x equal? Plus or minus square root of 4/3. Which you can write that different ways, but that's one way to write it. Okay? So where is the tangent line horizontal? At x equals plus or minus the square root of 4/3. And you can find the y. The y value would be related here. They asked for the y value too. Okay? But at x equals plus or minus the square root of 4/3, which is, I guess it's a little bit over 1 point something. 1 point something and negative 1 point something. So that's where this equation, tangent line, will be horizontal. Okay? All right, so that's a little tricky there. Something we hadn't talked about. The other thing, too, that I wanted to mention is, we've got dy dx, which is the first derivative. What if we had a second derivative? What if we want to do a second derivative? Because sometimes we're interested in second derivatives and beyond, too. So here's one with second derivative. Find y double prime, second derivative, for x squared minus 4y squared plus 2y equals 5. Okay, well, what is the second derivative? It's the derivative of the first derivative, right? So I start here by just getting the first derivative. And the deal is, on this type, it's implicit. I've got to do some implicit differentiation. Matter of fact, it'll wind up being both of them be implicit, but let's see where it goes. All right, so find the first derivative first. Before we find the second derivative, we've got to find the first derivative. Find the first derivative, we've got to do our implicit differentiation, d dx. All right, so what's the first derivative? Well, the derivative of that would be 2x. What about the derivative of that? It'd be minus 8y dy dx. Does that sound okay? Bring down the power, subtract 1 from the power, and then it's a y, so we've got to do dy dx. Same thing here. A derivative of 2y would be 2 dy dx, because the derivative of y is 1, but it is a y, so we've got dy dx equals 0. Derivative of 5 is 0. Okay? So, I've got to move 2x over, so we have minus 8y dy dx plus 2 dy dx equals negative 2x. Factor off the dy dx on the left. We have negative 8y plus 2 then in parentheses equals negative 2x. And so dy dx divide off the negative 8 plus 2y. So we get dy dx equals negative 2x over negative 8y plus 2. And if you see it, you don't have to, but if you see it there, if I factor off a 2 here, I can cancel the 2 on top and on the bottom. So let's go with dy dx equals negative x over negative 4y plus 1 or 1 minus 4y, whichever you prefer. Okay. But that's just the first derivative. That's y prime, also known as. I'm interested in second derivative, y double prime. So how do I get y double prime here? Well, I'll just do the derivative of this, right? If that's y prime, then y double prime is the derivative of this thing right here. What am I going to have to do to calculate the derivative of this right here? Quotient rule? It is quotient rule, but it also is implicit here because we've got the y and the x. So let's see if you are with me here. If I do the quotient rule here, low d high, so it'd be negative 4y plus 1 times the derivative of the high, negative 1. Minus high, which is negative x, times derivative of low. All right, what's the derivative of the low? Derivative of negative 4y, what would that be? Negative 4 dy dx, okay? And then the derivative of 1 is 0, so that's it. Negative 4 dy dx, derivative of the low. Over, though, don't forget, low squared. Okay, so clean that up a little bit. That'll be a positive 4y minus 1, wouldn't it? Because we distribute the minus 1. Here I've got a minus, and a minus, so that's overall going to be minus 4x dy dx over negative 4y plus 1 squared. Which is a pretty good answer. However, let me tell you something we could do here. You see here, y double prime is actually in terms of x and y and dy dx. What if I wanted y prime only in x and y terms? Well, couldn't I go ahead and substitute what we know about dy dx? Dy dx is this right here. So I could, to make it only in terms of y and x's, y double prime, second derivative would be 4y minus 1 minus 4x times this right here. It would be minus x over negative 4y plus 1 over negative 4y plus 1 squared. And you could do algebra things to that. Make it a little prettier, but you get the idea. That gives us something, well, we can just plug in, give me a x and a y value, I can tell you the second derivative. If x is 1, y is 3, I can plug that in and give that right to you. The second derivative's value. Okay? With me on that. Question